Yes, thanks very much, Lucy, Ben, everyone at the Digital Greenhouse for providing me with the opportunity to talk today. I think, yeah, as Lucy said, just very briefly, my background is, so I've worked for Frontier Economics for about 5 years now, in a range of different roles, doing different types of things, all with data. But sort of over time, what I found myself doing is working more towards the policy issues that governments face, and yeah, using data to help them establish an evidence base and ultimately make policy decisions based off that, specifically in the areas of skills, digital, and trade. So that's a bit of background on me. The other thing to say is I grew up in Guernsey, so I might have some insight on Guernsey data sets, might potentially not as many as you, but I'll provide some thoughts on that as well as we go through. There's quite a few things we can talk about in data. So I've made an agenda. So basically, I think this session will probably go into two main bits. So firstly, data science. Why? Why are we here today talking about data? Why are organizations using data increasingly across the economy? What's the reason for that? And then also, how do you do it well? And then probably pause for some questions after that. And then after that, try to bring to life some of the tips and guidance in the how part, with looking at the economics of two key issues in Guernsey through 8 charts, and seeing if that can bring to life some of the guidance that I'll offer up in the first bit. And then we'll also have a bit more Q&A at the end. I put it as discussion because if I was in person, I'd be looking for a sort of a two-way discussion, hearing about your experiences using data, and please feel free to put those in the chat as well. But we'll probably have to stick a little bit to questions and answers in that last bit. And actually, the other thing to say, just before we start, is in the spirit of making this as interactive as we can, I think Ben and I have prepared a couple of poll questions. And they're obviously related to data. It's not just anything. So I don't know if Ben, you want to put the first poll question up now, and you can feel free to put your answers in. That is appearing on my screen, so I need to get rid of it. Okay, cool. Yeah, and actually, sorry, just before we crack on, other thing to say is I understand that there's a real variety of people in the audience today. So I know that some A-level students will want to have a look at this presentation. There are some people from business, government, people that maybe work with data, haven't worked with data that much. Because of that, it's going to be a bit challenging to perfectly tailor the presentation to everyone. What I'd ask you to do then is, if anything doesn't make sense, or if you want to really explore any of these issues in more detail, please just put a question in the chat, and I'll pause in a couple of places for Q&A, and we can come to it then. Anyway, good. Let's begin. It's 9:10. So I think this first slide is just basically serving the purpose of trying to split out a couple of things of how data is used. So I think as a lot of you will probably be aware, there are businesses that base their entire business models around data, and potentially a well-known example of this could be Facebook, which will collect data on its users and then sell that data to other organizations, potentially use that data for advertising purposes as well. And really, data is the be-all and end-all for these companies. It is part of their core value add. And I just think it's worth separating that out from other aspects of data use by organizations, governments, businesses, what have you, which is basically to improve decision making on issues which also have their own value add. So it's more of an indirect way for data to add value, improving the quality of decisions and the speed of decision making, and so on. And as economists, inevitably, our focus is more on number two, and that's what we'll be talking about today. I just thought it would be helpful to split those things out at the start. So a little bit on why, and I'm not going to go through each of these, but it is true that data is increasingly being used to make key decisions in society. It's a really, really important input to the decision-making process. I guess to pick one of these, governments, which is probably the area where I've got most insights. You know, if governments are looking to make decisions for the benefit of a wider community, society, population, workforce, it's really important for governments to understand what their population, workforce, etc. looks like. There are big benefits of doing this, and a particular example could be skills, to bring that to life. So with skills, if a government is able to collect data on the qualifications of individuals across its entire workforce, that could then enable that government to actually, when it thinks about policy interventions, policy options, really target upskilling, reskilling programs to people that would have greatest benefit from those programs, and whether that's individuals with, I don't know, a potential type of qualification that could be changed in some way, you know, could be reskilled in some way, or whether it's really looking at individuals that already have qualifications that could build on those with more skills. The targeting role of policy making is really important, and data is a key resource that governments can pull on in order to do that well. And the other areas as well is policy appraisal. So before policy is enacted, is implemented, the costs and benefits are valued in order to determine the business case for it, and clearly data is a really important part of that process. And then monitoring and evaluating, understanding whether the policy is working and why it's working is super important insight for informing future policy development. So all of those things for government is where data can come in and play a really important role. And there, you know, clearly governments aren't the only organizations in society using data. You've got businesses, regulators, and consumers as well. Very happy to go into any of these in more detail, but maybe just for the sake of time, I'll just ask if anyone's interested in that, they could pop a question in the chat and we go from there, just to keep things moving. So how do you actually use data to, oh, I've got notes. I wasn't aware that I had notes for this. Anyway, so how do you actually use data to really generate insight that can then form part of an evidence base and ultimately help to inform decision making? Well, at Frontier, we've got two main ways that we use data science to generate insights for our clients. And actually, just to say, this is all in the context of a, you know, consultant-client relationship, but it really doesn't have to be. And I think that these methods will also extend to, you know, someone just working in government or in business and doing a piece of work for their project manager. I think it's the principle will be exactly the same. So the first group of ways of thinking, if you like, identify and visualize. So this is where we think that you can use data to help clients understand what is happening in their environment on issues and outcomes that matter to them. And the way that we use data to do this is really summarizing information. So collecting it, summarizing it, breaking it down into something that's more digestible, but also using some techniques to group parts of a target population, and then have a look at real world patterns that happen across those groups, between those groups. And like I said, this will help businesses, governments, etc., to have more of a bird's eye view. So again, going back to the skills example, really understanding what the breakdown of qualifications looks like across your workforce would be a really helpful resource for government in order to inform skills policy. And in terms of the actual statistical techniques, so very simple descriptive work can actually get you an awful long way. So just the way that you organize a data set and then, I don't know, divide one variable by another variable to get a proportion, that sort of thing, and then look to just visualize how those variables look across your population, just using very simple, basically simple maths can get you quite a long way. The other way that you can do it is clustering, otherwise known as unsupervised machine learning, where you get an algorithm to do it for you. I won't go into any detail on that, but that's just a way to group different parts of a target population where an algorithm does the grouping rather than an individual. And then the other thing to say actually with this identifying and visualizing, in order to really understand what the visualization means for you as a business or a government, it's often helpful to have a point of comparison, and that's where benchmarking can come in handy and compare to other jurisdictions in the case of Guernsey government, etc. So that was the first set, and then the second set is the more techie stuff. So this is about explaining and predicting. It's really trying to get to the root cause of outcomes that you would observe in the world. So it's unpicking that cause and effect linkage. And the reason why it's valuable to do this is, this understanding why something leads to particular outcomes. If you're a business or a government and you want to you want more of a certain type of outcome, understanding the reason why that happens can enable you, empower you to change the outcomes that you'd like to observe. And then on the technical side, I won't go into the last three of these in any detail, but I think it is worth just talking about econometrics very quickly. So I love econometrics. It's a bit of a nerdy topic, but I'm sure a lot of you would have probably come across the phrase correlation is not causation. And in the same way that, say, my age is correlated with global temperatures doesn't mean that I am responsible for climate change. It's really important when you see a correlation in the world to try and unpick what the causal link actually is within that. And econometrics is a whole suite of techniques that you can use to do that. I'd love to go into more detail, but maybe the best thing for now, in the interest of time, is to just leave it, and you can ask questions on any of this if it interests you further. And then this is moving more into the how do you do data analysis, and what do the different parts of a data stream really look like? So the first thing to say is it's probably more fluid than this, and it's not necessarily a linear process that will translate exactly across time. But essentially the key inputs that you have at the start of a process of data work is, as an individual, you will be observing behavior on customers, which are the four, or indeed just the wider population, which are the four people on the left hand side. And then you will look to capture or collect information on those individuals and then store it. After you do that, there will be a cleaning process. You'll need to think, you basically interrogate the data in a bit of detail, understand if it makes sense. If you have missing values, are those because information is genuinely not available, not applicable, or is it because they're actually zeros? It sounds silly, but these things can really, really impact on your results. So there's a cleaning process. And then the other thing that it's really helpful to do at the start as well is, when you build up a master data set for analysis, trying to link in other data sources as well is really, really useful. So actually going back to the skills example, where you might have, say, individual level data on qualifications across individuals in a data set. If you also have another data set for the same individuals, which says what sector they worked in, if you're able to combine those data sets together to merge them, that's actually really helpful for delivering far more precise, valuable insight. You could start answering questions like, what does the qualification mix look like within a particular sector, as opposed to the whole economy, which clearly for government that may be interested in some sectors more than others, or interested in targeting sector-specific policy making, you can see that type of additional information would be really, really helpful. And then after that, there's the analysis and the visualization stage. One thing to say here is throughout all of the collection and the cleaning process, and also the analytical stage of the data work, you'll often be using a data program, which is what the second sort of column of images is for. There are different options here, and I'll talk about each option in a little bit more detail on the next slide. But picking the right program for your analysis from the outset is really important. And actually within this, I think Excel can get you quite a long way, but we'll come into that into more detail. And then the last thing to say is, once you've generated results, it's really, really important to interpret them right. And there are different things that you should think about in order to do this well. The costs of not doing the right interpretation are quite big. If you reach the wrong conclusions from a piece of data analysis, and those conclusions form part of evidence which ultimately informs a policy that will affect lots of people, or a business decision that will affect lots of revenue for the business, making those incorrect interpretations, there's quite a big cost and risk attached to that. So it's really important that you get that bit right as well. I'm just wondering, actually, Ben, is it worth putting the poll results up before I go into a bit more detail on the process? Because I know we asked a poll question earlier. Here we go. So UK demand for workers grew by 36% over the past 5 years, but how much did demand for data scientists grow? So a lot of you think 40 to 60%. Most of you think 60 to 100%. That's quite interesting. So almost doubling. And then about a third are saying that demand for data scientists more than doubled. If you said that it more than doubled, you're absolutely right. It actually more than tripled. It increased by 231%. So yeah, it's clearly a really growing profession. I think there's probably a derived demand for labour, if you like, based on the importance of using data in decision making. And that's where those results probably come from. So here's a little bit of guidance on a bit more of the how behind data work. So how you can follow an approach to really manage data work well. I think it's worth calling out at the start that there are two particular risks with data which are different to other types of analysis if you compare to, say, a literature review that you might do. So I think the first risk is blockages. So if you have an error, whether you're using code in R, Stata, Python, or whether you have constructed a spreadsheet that just has a series of error values in it, you will need to basically correct and resolve that error before you can do anything else. And that basically brings a different kind of risk to the wider process of doing data work. And the other thing to say is, if you have a really granular data set, there are so many different ways that you can go with a piece of analysis, and it's quite easy to find yourself going down rabbit holes, getting lost along the way. What both of these things mean is actually, in terms of tips, guidance, there are a couple of things to think about for the wider approach to how you manage data work. So firstly, it's really helpful to think about the wider framework that you're looking to follow. So to set up, so basically to ask yourself, what are you really interested in? What is the aim of the data analysis? And then to try to break that aim or question down into more detailed questions or hypotheses to test using a conceptual framework, that's a really useful thing to do. It will basically help you to streamline your analysis, keep it focused on the most important things, but also to manage the scope of the project. So if, given that data work is potentially quite risky, if you need to deliver a piece of work to a deadline, it's far easier to be able to manage the scope of what you do and strike out a hypothesis or two if you are thinking about the wider framework, and thinking about how everything flows into the ultimate question you want to answer. It's a lot easier to manage the scope of what you're doing in that way, as opposed to basically diving into the data from the start and just looking at it and going in different directions. It's a lot harder to perform the data analysis in a controlled way if you go that way. And the other thing to say is, in the analyze and visualize part of the process, really good to just try and keep the analysis as clear and simple as possible. Part of the reason for this is the insights will be more helpful if they're easy to understand. And there's clearly a communication point in all of this, but also typically the simpler the analysis that you do, the simpler the insights are, and the more clearly you're able to communicate them. And the other thing to say there is, in terms of how you think about what analytical approach to take in the analyze and visualize part, I think it's a really challenging thing, because there's so many different ways you can go about it. One rule of thumb that I find really helpful is, if you try and think about the insight that you're trying to get, and let that really guide the analytical approach, that's basically a good way to thinking about data work. And so those were more about managing and the wider approach behind a data work stream. Here's some thoughts on how to execute data work well. So I mentioned earlier Excel, Stata, R, Python. It's really important throughout the collection, cleaning, and analysis phases of data work to pick a suitable program for analysis. And there are, several reasons for this. It's basically, it doesn't make sense to jump between programs. That can introduce risks if you don't copy data overwrite, things like that. So it's good to stick with one and think about what the right one is. And in the context of Guernsey work, Excel is probably going to be fine for the majority of data work in Guernsey. But I'd never kind of discourage people from learning R or Python or others as well. It's also important to really invest enough time at the start of the process interrogating the data, understanding if there are any errors with it, cleaning it, matching it up. And that's because, and I've had it done to me. If there is a mistake in the raw data and it flows through, the analysis process into your results, and you reach the wrong conclusions as a result of just a simple mistake in the raw data, it can actually be very time intensive and challenging to unwind the entire process, start again, essentially correcting that mistake. So it's really important to spend enough time at the outset, looking at the data, making sure that it makes sense. And then relatedly, it's important to interpret results at all stages, and already talked a little bit about interpreting your final results, but it's also important to build in cross checks throughout the process to pick up any errors that you might have inadvertently created through calculations and so on. I hope this all makes sense, by the way. I'm kind of going through with a bit of pace. We've got one more slide before Q&A time. I think we've got one question in the chat, so please put some more questions in. Anyone's got any questions on techniques, why data is useful, but also how to execute the process well, please just put them in. And then the last thing is, I said interpretation is super important. There are certain, again, rules of thumb that you can use when interpreting results. So the first thing that you could ask yourself is, are my results valid? You know, do they make sense? Is this what I was expecting at the start of the process? And that will basically drive you towards errors in the raw data, but also errors in calculations that you made. The other thing that's really important to ask is, are my results actually statistically robust? So you may well generate a particular set of results, but before jumping to conclusions and takeaways from those results, it's really important to ask whether the conclusions that you've generated are statistically valid. And, you know, and I mean, maybe to bring this to life a little bit more. So maybe one example is if, say that there's unemployment data that's been published for a single time period, a quarter, and it shows that lots of individuals who are unemployed have skills in, say, the retail sector or the construction sector. And the conclusion based on that one quarter of data, that one data point is, you know, we've got lots of unemployed resources for construction and retail, and we need to put these to use. And actually, as a result of this, government should go away and decide to, I don't know, to implement some kind of job program for people in the construction and retail industry. It's not clear that those conclusions would naturally, logically follow on from one data point. Those conclusions probably wouldn't be statistically robust. And it's really important to ask yourself that question of, you know, even if I see a statistic, how reliable is that for really informing decision making? And the other thing, sort of on reliability, and maybe a bit more towards representativeness, is asking yourself external validity questions. So when you do a piece of data analysis, you'll often do it for a particular subsample of individuals, companies, workers. It's worth asking the question of, do my results for this particular specific sample extend to the wider population as well? So if I want to implement a policy across the wider population, but I have results from a piece of data analysis that was only on a particular subsegment of a population, do those conclusions that I'm drawing from my data analysis naturally extend to everyone else? Because if they don't, and it's fine if they don't, then it may not be right to introduce an economy-wide policy on the basis of a subsample, on the basis of results for a subsample of individuals. And then similarly, you know, if you generate results for a particular period of time, absolutely worth asking the question, well, do my results for this period of time really extend to other situations? Do they extend to the current time period? Will they be replicable, or will they extend to the future? So I think that's a kind of a whistle-stop tour on why data is being used, why it could be useful, but also a bit of guidance on how to do it well. I hope it was helpful. We've got some, I think now's a good time maybe to pause for questions on this. Okay, great. So Phil Pragnell, what are your thoughts on using Microsoft Power BI data analysis? Is this a bit heavy-handed for most analysis and insights? That's a really good question. And Power BI is so Power BI is a tool that you can essentially use to, as far as I know, to insert data into and to visualize results in a certain way. The question that I would ask is, with Power BI, are you also, because I'm not super clear on what it can and can't do, with Power BI, is there also a process of cleaning and collecting and matching data sets? Because if that is the case, my inclination would be to try and stick with one program, because using multiple programs will introduce risk into the wider process. So, but that being said, I know that Power BI does have some helpful visuals that it can create, and helps you look at data in a certain way. Depends a little bit on how much time you have, what the risks are, yeah, and how you feel about the risk of getting things wrong. If you're doing maybe a report for, yeah, someone potentially more senior, then it could be a bit more risky, and you might want to stay away from doing that. Jake has come in with a question of how do you set realistic expectations for what analysis is possible when there are only a limited amount of data sets available? So that's a really good question on, so I guess this goes more towards the communication side of it. I think this is really hard because you'll often find a situation where, you know, we would have it in consultant-client relationships where someone would say, oh, can you do this? Can you just add this extra bit of analysis on? Can you do another piece of work for us? Relatedly, you know, it should be simple, right? You've got the data, or there's an assumption that the data exists. This is difficult. It's, I think, one of the ways through it can often be understanding, pushing the question back to the person that's asking it. So if someone's asking you to do more analysis, if you are able as the data analyst to basically say, why are you interested in that? Then if you can see ways that, you know, if the analysis they're suggesting isn't feasible, if you can find reasons and ways for saying why conceptually answering that question wouldn't be as helpful as answering a different question, that can help. In terms of unpicking the kind of the operational issues and the difficulties behind doing pieces of analysis, this is just a difficult thing. I think it will come with experience. I can't particularly think of any advice that I'd have. The more visual you can make things, the better. So if you can actually show someone why something's difficult, then that's helpful rather than talking about it in the abstract. But yeah, I'm not sure how much that answered the question, Jake, but I hope it helps a bit. And then we have, I think we already had a question from Phil, so I'm going to go to Adrian next. If you have a vast data set and the outcome being sought is fairly broad, e.g., how do we improve productivity? How do you avoid going down the rabbit holes you referred to? This is such a good question, and I think it relates back to one of the main risks of data work that I talked about a little bit earlier, which is, you know, there are so many different directions you can go in, particularly if you have a really, I don't know if vague's the right word, but a very general question like how do you improve productivity? I think this is where the conceptual framework comes in. So understanding what you're trying to achieve and why. And then if the core question is how do we improve productivity, breaking that down into the different elements of productivity. So that could be, I don't know, skills, infrastructure, maybe digital connectivity as well. If you can kind of compartmentalize that bigger question into more specific questions within an overarching conceptual framework, and then from those more specific questions, so going into skills, ask or think about the hypotheses that you'd like to test as a result of those, that can be a way through the process of doing a piece of data work that would ultimately be useful, relevant, and targeted in order to answer the overall question. I'm not sure how well that was explained. I hope that's helpful, but Adrian, please follow up with another question if you think that wasn't clear. And then Phil, to come to your question, how do you cope with very large volumes of source data? Sometimes I find Excel can struggle with many 100K rows of data. This is a really good question. And this goes back to what program you used to clean, organize, and then analyze your data. So Excel is great because it allows you to, for relatively small data sets, because it allows you to see what your data looks like, see the calculation steps that you are taking in different worksheets, different tabs, all at once. So you can kind of get that bird's eye view on the piece of data work you're doing. Where Excel runs into difficulties is when there is a large number of calculations that it has to perform, and then it can struggle a bit with processing as a result of that. So in the example that you said, I find Excel can struggle with many 100,000 rows of data. Yes, absolutely, that's not surprising. And in that instance, it would be useful to use a different program such as R or Python or Stata to clean and manipulate your data and then analyze it in there. So I think that's the Q&A. I'm going to have a little look at time. So we've got 20 minutes left.
Oh, Rob, can I jump in and ask a question actually?
Yeah, of course. Yes, please.
It's a question that actually was asked on Monday at the opening breakfast for Data Week, but I think it would just be interesting to hear your view on it as well. I'm going to paraphrase the question because I won't remember it exactly, but we had an audience member who asked, in Guernsey, there's a lot of surveys that we see pushed out from lots of different organisations.
Yep.
It sort of feels a little bit like every week there's a different survey coming through. Yep. And the question that was asked on Monday was how reliable survey data is, or how much we should maybe use that form, or is there a better way of getting information? So I just wanted to sort of pose that question to you and see maybe what your response is.
It's great that people are picking up on this as a question, and it absolutely true. And I know from my time back home that a lot of surveys are done, and the results from surveys are a big part of an evidence base for making decisions. I think there are so when you ask people, well, actually, I guess going back a little bit to first principles, the reason why data can be really helpful is it tells you something about the behavior of individuals and people. I think it's worth drawing a distinction here. So there is a difference between what people actually do and what they say they do. And there is an entire behavioral literature, in behavioral science, psychology, a little bit of behavioral economics, explaining why what people say they do is not the same as what they actually do. So there are things you need to think about when you do surveys, and there are definite drawbacks from surveys, but they also have their uses. You need to think really carefully about how to design a survey. The other thing I'd like to say on this is actually going back to the external validity point. What is your sample of what is the sample of people that you've surveyed? Is it representative of the wider population? And then basically asking the question of, if I produce a piece of survey analysis or go out and collect data through a survey and run a piece of data analysis off that data for a subsample of the population, and I start forming conclusions based on that data on a subsample of the population, is it really true that the conclusions that I'm forming on that subsample extend to the wider population as well? So I think there are a few risks that you need to keep in mind with survey work, and some alternatives could be there are other ways to collect data as well. Probably won't go into the detail on them now, but yeah, State's data and analysis team do a lot of data collection, and that is one very good alternative to surveying people. Any other questions quickly? Oh, we've got one. For people starting out in data analysis, what would you recommend they study? A-level maths, statistics, economics, computing? That's a great question. I mean, it's a bit challenging because in the spirit of thinking about external validity, all I can call on is my own experiences, and it's not immediately obvious that those would extend to everyone else. But one of the things that I really love about my job in applied economics is it's thinking about behavior, outcomes in the world, influencing, decisions, outcomes that are made in the world that really matter. And data analysis is such an important part of that. I think there is a real benefit to having a really good core knowledge of statistics. You don't have to go as far as econometrics necessarily, but being able to do basic statistics really, really well is useful for data analysis. But I mean, if we're thinking about skills, a lot of the sort of the guidance that I talked about and the ways of how to do a piece of data analysis that I talked about earlier, a lot of it comes down to project management, time management of a process as well. So there are a range of things. Statistics is particularly helpful. I think economics would be helpful. Computing could be useful, and we're seeing a wider trend towards more data being used, data needing to be processed. So computing could be very helpful in that. But at the same time, I know for a fact that I didn't study computing at any point, but I have picked up how to learn Stata, which is a computer program. So you can always learn it in other ways as well. But yeah, maybe adult computing courses could be helpful. It's not a necessary one for A levels, I think. Cool. We had another poll question, but actually I'm going to skip it if that's all right, because I think we're getting a little bit short on time. And I'm quite keen to get to the economics of Guernsey and 8 charts. So one of the other things that we did, myself and a colleague, is we had a great time going through the data and analysis supplementary Excel tables to have a look at some Guernsey data. And what we've done is we've produced a series of charts on 2 key issues that are relevant for Guernsey and indeed are being discussed in Guernsey at the moment. The aim of this is really to try and maybe bring to life a bit more how you can generate insight from data analysis through the identify and visualize part of data techniques. So what I've got here is the economics of Guernsey and 8 charts. I think we've got about 10 minutes left, so I'm probably going to slim it down to 5 charts and just kind of talk you through it. Hopefully it'll only take 5 minutes, and then we'll have some time for questions afterwards as well. Other thing just to flag at the start of this, trying to use these charts as a way of trying to generate or show how insight can be generated from data in order to help you think about issues in a different way. Not thinking about what the policy implications for any of this is, and explicitly would like to not have to answer any questions on policies coming out of any of these charts, if that's all right. So skip the first 3. That was on the macroeconomy. So a really big issue for Guernsey at the moment, as we all know, connectivity. And obviously connectivity can kind of be split into a couple of things. So there's trade, freight, so the movement of goods and services. And then there's also, but particularly goods, but then there's also passenger movement and air. That'll be more air connectivity. But starting on freight, something that I found interesting is, so what we can see from this chart is Guernsey imports an awful lot more than it exports. In some ways, that's not surprising. We would expect a relatively small island in the middle of the English Channel to import a lot of goods. But what potentially is a bit more helpful and something that I found a bit revealing is the scale of magnitude of the difference. So the fact that Guernsey imports 7 to 8 times the tonnage that it exports, I think is quite revealing, useful, and probably hopefully adds a bit more insight over and above just saying Guernsey imports more than it exports. The other thing to mention isn't shown in this chart, but it is very relevant. 99% of imported tonnage is by sea. And I didn't know that. And that's, to me, that seems probably even higher than what I would have expected. So potentially interesting. And then, as I said, the other side of connectivity is passengers. And this chart essentially shows the total passenger movements over the last 20 years for both air travel and sea travel, either side of the horizontal axes, which is the red line there. It also shows the breakdown of the destinations of passengers across time as well. I think there's probably a few things to take from this. Firstly, air travel is more important than sea travel for passenger movements. You know, it's a fact that air travel across the last 20 years has probably accounted for almost 3 times as many passenger movements than sea. If we focus in on air travel, if we look at the height of the bars across time, potentially a slight decline in the number of passenger movements over time, maybe relatively constant, slight decline. The other thing to say is, if you look within the air travel passenger movement bars, the composition of air travel movements has changed across time. There's probably been a slight increase in movements to the UK. And at the same time, there's been a slight decrease in continental movements and also inter-island air movements. So the UK is clearly an important destination for passengers, and there's a slight upward trend in that as well. And here's a map that, well, actually, going back to identify and visualize a little bit. One of the things that is really useful that I think I mentioned before is if you can compare results from a piece of data analysis to a benchmark, then that can be quite revealing on what your data analysis means for policy making and other things. And in Guernsey, we're actually really lucky that we have Jersey right next to us for the purposes of benchmarking. So this what this map does is compare basically the connections, the air connections from Guernsey to different airports in the UK and also in mainland Europe, and it also does the same thing for Jersey. And what you can take away from this chart, I think, is Jersey operated more routes in 2019 than Guernsey did. So it operated 31 compared to Guernsey's 22. The coverage of routes in the south of England is relatively similar. So the white dots, which is where an airport is connected to both Guernsey and Jersey, there are lots of those white dots in the south of England. And in fact, there are some yellow dots where airports are connected to only Guernsey as well. Those are Stansted and Heathrow. But as you go further north, you see more red dots. And essentially what this is, I think, is telling us is Jersey operated more routes to the north, Scotland and Ireland than Guernsey did, and actually quite a few more routes, 8 more routes. And potentially that is the difference which really drives the overall difference in the number of routes operated from Guernsey to Jersey. So I thought that was quite interesting. I didn't realize the scale of magnitude of the difference in number of routes to the north of England between Guernsey and Jersey. And what we also did was looked at how the difference in route coverage actually leads to differences in passenger movements between Jersey and Guernsey to different parts of the UK. So we took there's a data source that we have access to, OAG data, that basically has information on the number of passengers flying between 2 airports on a yearly basis. So this is for 2019. What we did was we summed up the total number of passengers for different airports in different UK NUTS 1 regions. So there are 11 UK NUTS 1 regions: Southeast, Southwest, Scotland, Wales, etc. We did that summation for both Guernsey and Jersey, and then we looked at the proportion of passengers. And then we divided basically for each region the number of passengers flying from Guernsey to that region by the number of passengers flying from Jersey to that region. And again, I think what this chart probably shows is, well, actually, just before we go into it, it's also worth saying something about the shading. So the darker the shading, the higher the proportion of passengers. So if you have really dark red, that means that for every Jersey passenger traveling to a region, one Guernsey passenger will also be traveling to that region. And what I think, what the insight is that you can take from this chart is the difference in coverage of air routes from Guernsey and Jersey does also feed into differences in passenger numbers traveling to different parts of the UK. So in the south, you can see that there's a lot of dark red. You know, the proportion of Guernsey over Jersey passengers might be close to 100%. For every Jersey passenger, there's a Guernsey passenger traveling there. As you get further north, if you actually group the northern NUTS 1 regions in Scotland, it's the case that for every one Jersey passenger that travels to those regions, only 0.2 Guernsey passengers will also travel to those regions. So the sort of the lack of air coverage in the north of England and Scotland from Guernseys flows through into fewer passenger movements to those regions as well, at least compared to Jersey. I'm actually really conscious of time, so I think we've got 4 minutes left. I don't know if there are any other questions. I haven't seen anything from the Q&A. Hopefully that was helpful to try and bring to life a little bit more how you can use data analysis to identify and visualize different things and provide insights that could be relevant for decision making. If you've got any questions, please put them in the chat now. We've got 5 minutes. Otherwise, I don't know if Lucy, Ben, you might have something else that you'd like to ask.
I'd be quite interested to see, Rob, just the slide that you had that you jumped over before. So I think that the airport ones are really, really interesting, and the travel one. As we've got 5 minutes, is there a chance to look at the other graph that you had?
Yes, of course. So is this the one you want?
Yeah, that'd be great.
Yeah. So this is just taken from Guernsey Facts and Figures. This looks at the evolution of gross value added over time for different parts of the Guernsey economy. And I think there are some takeaways here. The main one is probably just the size of the finance sector, which probably isn't news to lots of people, but it accounts for about 40% of GVA. And if we move through, though, if you look at the percentage change in GVA over the last 10 years, actually there's some quite revealing insight. I think that the fastest growing sector is actually professional services, which is down, I think it's PBST in the state's data. These are things like, as I understand it, law firms, engineering, I think architecture might be in there as well, but actually so that's grown almost at 10% per year. And if you actually look at on the right hand side of the chart at finance as well, that's actually grown slower than wholesale and retail and hospitality. So something that I thought was quite interesting, and maybe actually a point to make through this is, again, picking the type of chart you want to use in order to tell the insight that you think would be interesting is a useful way, because I don't think that what I just said, the insight that I just gave, necessarily came out through the previous slide, but I think it does come out more clearly through this one. And actually, you can get an awful long way through a really good bar chart. I think bar charts are underrated. I don't know if we have time. We've got 1 minute. But if we do a bit of a deep dive into the finance sector, we can see that although it has steadily grown on the previous slide, the growth rate I think was 0.7% per annum. If you look at the composition of finance over time, the composition has definitely changed, and the main thing to note is that banking has shrunk substantially by almost a third over the last 10 years, whereas funds and the investment sector has almost basically doubled in size over the last 10 years. So I think it's quite handy. Maybe this is something about thinking about how to use data in order to answer a question in a more controlled way. It could be helpful to basically look at, the different sectors for Guernsey as a whole, how they've evolved over time, and maybe draw the conclusion that finance is 40% of GDP, but then use that information as you go along to then dive into more into different areas that could be more or less interesting. And one of the areas that could be looked into in more detail would be finance. So maybe something about using data to perform a piece of analysis in a more controlled, organized way as well. But I think that's it.
Are there any final questions from anybody? Excellent. Thank you very much, Rob. I think a really, really interesting presentation. I think both from a practical standpoint, but also thinking actually from quite a wide view of what does this mean for Guernsey, some of those models as well for viewing the data. We will be sharing the recording of today's presentation and the slides with you over the coming days. So thank you very much for attending. We do have a couple of final events for the week coming up, so please do pop over to digitalgreenhouse.gg to have a little look at the events for the rest of the week. But thank you, Rob, and thank you for everyone attending.
Thank you, everyone. Yeah, have a nice remainder of Data Week and an enjoyable weekend as well. If anyone's got any other questions, please do reach out, and very happy to talk more about this stuff